Hello students, welcome to the amazing platform of Physics Wallah. Welcome to the PW English channel, my dear students. We have reached on the fourth lecture of solid state. I hope all of you are excited because we have covered a lot of things till now. We have studied how to calculate the rank of a unit cell. Also, we have calculated the ranks of the different unit cells which we have discussed till now. And also, my dear students, in the previous class I told you what exactly is packing fraction, how do we calculate the packing fraction, and we calculated the packing fraction for primitive unit cell. Also, we did calculate the coordination number of the primitive unit cell. Now, my dear students, we are going to move forward. Let's see what are we going to discuss today. We will be continuing the packing fraction and coordination number part, and we'll be calculating both of them for the body centered as well as the face centered unit cells. Okay, so let's start the session again, my dear students. We talk about the body centered cubic system. So if we talk about the body centered cubic system, we have to calculate its packing fraction as well as we have to calculate its coordination number. Okay, so we know that first we have to draw. Yes, we have to draw your body centered unit cell. Okay, I think this is a square. Okay, so this is your square. Okay, now so now, my dear students, in a body-centered cubic system, I know what is the arrangement here. Body-centered is the arrangement and this is the crystal system, right? Yes, body-centered means you have atoms present at the corners and also you have atoms present at the center of your body. So this is the body center where atom is also present. Okay, so if we talk about the packing fraction, in the previous class, we said that packing fraction is actually the volume of atoms divided by the volume of cube, right? Yes, and the formula that we derived was packing fraction is equal to rank into 4 by 3 pi r cube upon a cube, right? Yes. Now, the first and the most important thing that we need to calculate is the rank of a body-centered cubic unit system. So, my dear students, the rank for a body-centered cubic system would be NC by 8 plus NB, because it does not have face centered electrons or atoms or end centered atoms, right? Yes, so this would be 8 upon 8 plus 1, which is equal to 1 plus 1, which is equal to 2. So you have effectively two atoms present in the cubic crystal system. Okay, so this is how we calculate the rank of a body centered cubic system. Now we have calculated the rank, but we need another thing, which is the relation between the radius of the atom and the edge length of the unit system. How are we going to calculate that? Now, my dear students, here one important thing to be noted is that in the primitive unit cell, I told you that the atoms are in direct contact to each other. The atoms are in direct contact to each other along the edges. Yes, but in body centered unit cell, my dear students, in body centered unit cell, the atoms are not touching each other along the edges. So you can write this as note that atoms are not in contact at the edges. Rather, my dear students, in a body centered unit cell, your atoms are in touch with each other at the center of the body. That is, along the body diagonal, the atoms touch each other. Okay, so what I want to tell you is that here the atoms are not in contact with the edges, at the edges. Rather, atoms are in contact to each other along the body diagonal. Okay, this is something which you need to keep in mind. So what can I say? I can say that the body diagonal which I had here, my dear students, your atoms, you have one atom at the body center. So let's say this is the body center atom, and let's say this is your atom at the corner, and this is your atom at the other corner. So I have drawn this particular part. Let's say this is A, this is let's say this is B. Okay, now I have to calculate the length of this particular part. Only then I can find the relation between the edge length and the radius. So how am I going to do? I'll have to use the Pythagoras theorem here, my dear students. Yes, which triangle am I going to consider? I'll consider this triangle. Just see, this and this triangle. This is the triangle that we will be considering. Let's call this as C point. This is your C point. Okay, so I am considering the triangle this. Okay, here, my dear students, this is A, this is B, and this is C. So I want to calculate the length of AB. How can I calculate the length of AB? If I talk about AC, can I say that AC edge length is A? Yes, because AC is the edge length. Yes, ma'am. So this is A. This is clear to me. But now, what is AB? What is BC? What is BC, my dear students? Just see. Ma'am, BC is a diagonal. It is a face diagonal. It is a face diagonal. Right? Yes. So you need to calculate the face diagonal length. And how are you going to calculate the face diagonal length, my dear students? You know that it is at the center of a face, right? Can I say that this edge length is A, and can I say that this edge length is also A? We know this, right? Yes. So let's say this is some point D. So if I draw the triangle here, and I say that this is D point, this is your C point. Let's say this is your C point and this is your B point. See, B, D, C. Okay. So I'll draw it like this, otherwise you will get confused. This, and this. Okay, so this is B, this is D, and this is C. And you know that this CD length is A, and this BD length is also A. So let's put these values. Here you have A, and here also you have A, right? Yes, perfect, my dear students. Just a second, write this and then we'll move forward. I hope you've written this. Now let's try to understand this. See, you have edge length A here, edge length A here. Let's apply the Pythagoras theorem here. We can say that BC square will be equal to CD square plus BD square, right? Yes, this means that A square plus A square. So BC square would be equal to 2A square. So can I say that BC is equal to root 2A? Right? So this is root 2A. So my dear students, this length has came out to be root 2A. This is the length, so this would be equal to root 2A. Now we have to apply the Pythagoras theorem here. So try to apply the Pythagoras theorem here, my dear students. We'll say that AB square would be equal to AC square plus CB square. Right? Yes. So this would be equal to A square plus root 2A whole square. This would be equal to A square plus 2A square, which is equal to 3A square. So from here, my dear students, AB came out to be root 3A. So your AB value is root 3A. So can I say that this diagonal has came out to be root 3A? This means that, my dear students, that here this length is root 3A. This whole body diagonal is equal to root 3A. Okay, I hope everything is clear till now. I have calculated this triangle, your ABC triangle, and for calculating the CB length, I had to use this particular triangle, and here also the angle was 90 degrees. So I used the Pythagoras theorem and calculated their lengths. Okay, so this is how we did calculate the lengths. Okay, now what I want to make you understand here, my dear students, is that let me just check here. So now for calculating the packing fraction, I needed the length this. Yes, now I have this length. Let's try to incorporate it. Now I have this length, my dear students, which is equal to root 3a. So can I say that this is equal to root 3a? And I also know that there are the atoms are touching along the diagonals, something like this. And can I say that this radius is r, this radius is r, this radius is r, and this radius is r, because beach in center there is center point. Okay, so can I say that 4r is actually equal to root 3a? Your 4r is actually equal to root 3a. So r will be equal to root 3a upon 4, my dear students. This is the relation that you need to calculate. This is the relation that comes out for a body centered unit cell between the radius and the edge length. Now we will use this. Let's say that this is your first equation. Now we will use this relation in the packing fraction. Okay, so for calculating packing fraction, we know that rank came out to be 2 into 4 by 3 pi r cube upon a cube. I know that r is equal to root 3a by 4. I'll just use this into this. This will give me 2 into 4 by 3 pi into r is, my dear students, root 3a by 4 whole cube upon this would be r cube. A cube. Right? Yes. So let's try to solve this. This would be equal to 4 into 2 is 8 by 3 pi, and this would be 3 root 3 a cube by this would be 4 cube a cube, right? Yes, a cube will be cancelled by a cube. You will cancel 3 by 3. This 4 you will cancel 1 by this would be 2. So your packing fraction is equal to, just solve it, it would be, I think, root 2 into 2 root 3, yeah. So this is 2 root 3 divided by, you have 4 square. So I can say that root 3 by 4 into 2 is 8, right? Root 3 by 8 pi, and I hope I have done the calculations correct, and this packing fraction will come out to be nearly equal to 0.68. This would be equal to 0.68. Okay, so the packing fraction for body centered unit cell has came out to be 0.68. What will be its void fraction, my dear students? 1 minus 0.68, which is equal to this is 32 na, so 0.32, approximately 0.32 will be the void fraction for it. If you are asked efficiency, just multiply it by 100. Okay, yes, perfect. I hope it's clear. Let me make you revise this whole part again, because this was a little complicated, but yes, you can understand if you're clear with the concepts. Now what actually happens is, you have a unit cell, my dear students, and you have to make this a point that you know that the atoms in a primitive unit cell touch along a edge, but in a body centered unit cell, atoms touch each other along a diagonal, and that is the reason I made you write this statement. So read this statement, and now I know that atoms are touching each other along the body diagonal. So I need to calculate the edge length of body diagonal so that I can find a relation between the edge length and the radius of the atoms. So I used Pythagoras theorem, and I know that this is a 90-degree angle. So for calculating this, I know this edge length is A, but I don't know what is the edge length of this part. How can I calculate? It is a face diagonal. So obviously here also I can use Pythagoras theorem. So I used AA. This came out to be root 2A. Now since this is root 2A, this is A. So this came out to root 3A. Okay. So we calculated all the values, and then we incorporated it, and we found the relation, put the relation in the packing fraction expression, and we did calculate the formula of the value of the packing fraction. So for a body diagonal, the packing fraction comes out to be 0.68. Okay, and the void fraction will be equal to 0.32. This is how you calculate the packing fraction. I hope it's clear. If you want to write it, you can write it. Okay, perfect. Now let's move forward, my dear students. Now in BCC, that is your body centered cubic system, atoms must make contact along the body diagonal, and this is something very important for you. Okay, I have made you write this. It is also written here. You want to write it, you can write it again. Then the corner atom makes contact with the body center. Your corner atom actually makes contact with the centered atom and not with the edge atom. Okay. So the corner atom makes contact with the body center atom because one corner is shared by 8 cubes. The coordination number of the corner, now we need to calculate the coordination number. So let's calculate the coordination number. I'll make you understand how to calculate the coordination number. Again, for this we need a unit cell. Okay, so I'll make a unit cell for you here. Let's consider atoms present at corners and at the center. Okay, yes, I hope it's clear. Now what happens is, my dear students, you have to calculate the nearest neighbor or the coordination number. So how are you going to calculate? You know the minimum distance. Now let me tell you, if this whole body diagonal is root 3a, if this whole body diagonal is root 3a, can anyone tell me what will be this length? Since it is the center of the diagonal, this will be equal to root 3 by 2a. I hope it is clear. It is equal to root 3 by 2a, right? Yes. So the distance between this and this atom will be root 3 by 2a, which is equal to 1.7 upon 2a something, which is equal to 0.8a something, right? Yes. So the distance between these two atoms is 0.8a. And if I ask you what is the distance between these two atoms, you will say it is a. So I know that a is more than 0.8a. So who is the nearest neighbor? This atom or the body diagonal atom? Obviously, the body diagonal atom, the body center atom is at a minimum distance of 0.8a, and this will be the coordination number. The nearest neighbor will be this. Okay, yes. Since this is at the body center, now you have to calculate how many atoms are actually present at this distance, which is your root 3 by 2a or 0.8a distance. How can you imagine? Just imagine you have an atom there and you have to calculate the coordination number of that atom, and it is closest to this body center. Okay, yes, every unit cell will have an atom at the body center. Yes, this corner is in touch with how many cubes? 4 are these and 4 are above. And each unit cell will have an atom at the corner. Yes, ma'am. This means that it will be in contact with 8 corner atoms together. So what will be the coordination number of a body centered unit cell? It will be equal to 8, right? Yes. So I can say that the coordination number, the first coordination number or the nearest neighbor of your body centered is at a distance of root 3a by 2, and the number of atoms at a distance of root 3a by 2 are exactly equal to 8, because at 8 different cubes in the center a atom would be present. Okay, let's read this. The corner atom makes contact with the body center atom because one corner is shared by 8 cubes and each cube will have atom at the corner. The coordination number of corner atom will be 8. I hope it's clear that it will be equal to 8. Next, coordination number of body centered atom will not be 8. The coordination number of body centered atom will also be 8. Yes, for the coordination number if you are asked for the calculating the body centered coordination number, what will you say? It will be at a distance of root 3a by 2 to each corner, and how many corners do a cube has? 8. So the coordination number for that would also be 8. Okay, yes, because the body centered atom makes contact with 8 corner atoms. Okay, so you might have been asked the coordination number for this atom or this atom. Both will be equal to 8. I hope you're clear with this. Perfect, my dear students. If you want to draw this, you can draw this, and if you want to write this part, you can write it. I hope you've written it. Now let's move forward and calculate the packing fraction and coordination number for a face-centered unit cell. Okay. Yes. So try to do this on your own. First, try to do this on your own. After that, I am here. I'll definitely help you out. Okay. Let me tell you, the atoms will be in contact along the face centers. The atoms will be in contact along the face diagonal. Okay. If you want to write it, you can write as a note. Atoms will be in contact to each other along the face diagonals. Okay. I hope it's clear. Now try to do this on your own. Try to do this on your own. First and the most important thing is we have to find the relation between A and R. So first let's find that and then we'll calculate the packing fraction. Again, we need a unit cell. So this is the unit cell. Okay. In a face-centered unit cell, my dear students, the atoms are present at corners and face centers. So here it will be present here also, here also, here also, and here also. Okay. So the point says that this time the atom will not be in contact along the edge. They will be in contact along this face diagonal, So if I say that this is A, this is B, this is C, so I need to find out the length of this particular face diagonal. So this distance is A. I hope everyone is clear, and this distance is also A. I hope everyone is clear. So can I say that in triangle ABC, AC square will be equal to AB square plus CB square? AC square will be equal to A square plus A square. So AC square will be equal to 2A square. So AC will be equal to root 2A. So AC has came out to be equal to root 2A. So can I say that this particular distance is equal to root 2A? Right? Yes. Now we can find the relation. Because we know that here, how many atoms are in contact? Just see. You have a center atom, then this is in contact with this atom, and this is in contact with this atom. So I can say that this is R, and this is equal to 2R. Okay. So total 4R, and this 4R, this is your AC length. So 4R is equal to root 2A. So R is equal to root 2A upon 4, which is equal to A by 2 root 2. So the relation is AR is equal to A by 2 root 2. So this is the relation that we have found out between R and the edge length for a face-centered unit cell. You need to remember these relations, or at least you need to find out these relations, because questions will be asked based on this. Okay. Okay, perfect. I hope you're clear with this. Yes. So R is equal to A by 2 root 2. Okay. Yes. So now, my dear students, we'll calculate the packing fraction. Packing fraction will be equal to rank into 4 by 3 pi r cube upon A cube. I know that rank for a face-centered unit cell will be NC by 8 plus NF by 2. Right? Yes. You have 8 at corners and you have 6 at face centers. So this would be 1 plus 3, which is equal to 4. So the rank for a face-centered unit cell came out to be 4. Right? Yes. Now let's incorporate all the values in this. Your packing fraction will come out to be 4 into 4 by 3 pi r cube upon A cube. Let's find out the relation. You know that A is equal to 2 root. I can say that from here A is equal to 2 root 2 R. So let's put the value of A as 2 root 2 R. This would be 4 into 4 by 3 pi R cube upon 2 root 2 R whole cube. This would be 4 into 4 by 3 pi R cube upon 2 to 4, 4 to 8, 8 into 2, 16. 16 root 2 r cube. R cube will be cancelled and this value will come out to be approximately equal to 0.74. So the packing fraction for a face-centered unit cell comes out to be 0.74. So the packing fraction for a face-centered unit cell comes out to be 0.74. What will be the void fraction? 1 minus 0.74, which is equal to 0.26. Okay, so 0.26 is the void fraction. I hope you're clear with this. Perfect, my dear students. This is how we will calculate the packing fraction for a face-centered unit cell. If you want to write it, please write it. You can write this down. Also, you can write this down. Right? Yes, perfect. Now, we will be calculating the coordination number of the face-centered unit cell. So now let's try to calculate the in FCC atoms contact along the face diagonal. I hope you're clear with this. You want to write it down and then we'll move forward. Now we will be calculating the coordination number of a face-centered unit cell. I'll just make you explain how this comes out to be 12, but just write it down. The corner atom is common to 12 faces and it makes contact with 12 face-centered atoms. Now, when all the atoms are same, the face-centered atoms of adjacent faces make contact with each other. So, the coordination number of FCC is 12. So, the coordination number of FCC is 12. Okay. Yes. I'll make you understand each and every part. Don't worry. Just write it down and then I'll make you understand. Okay. I hope you've written this. Now let's try to understand how the coordination number came out to be 12. Okay. So for this, we need to draw the unit cell. I had actually made you understand this before also, my dear students, that when you have a unit cell, something like this, your atoms would be present here, here, and here, right? Yes. Also, they will be present at the face centers. One back and one front. Right? Yeah. So now, my dear students, which is the closest distance? They are in direct contact along the face diagonal. So I can say that this is the direct contact. So one here, and one, my dear students, this. I hope all of you can understand this. Yes. Now try to understand the coordination number. I made you explain this initially also. Now I'll make you explain it again. Now just imagine, my dear students, what if this one plane, you have one corner, you have three faces. So at each face you will have a center atom. So if I elongate this particular face, then one atom in this face, one in this, one in this, and one in this. So total 4 plus. Just see it. If I elongate this particular face, one atom in this face, one in that, and one in that. Total 4 plus. I had talked about this face and this face. Now let's talk about the upper face. Okay. So this face. One in this face, one above, one there, and one there. So total 4. So total you have 12 atoms in contact with this one atom at a by 2 root 2 distance, right? Yes. So this is how, my dear students, you can calculate the coordination number, which comes out to be 12. Okay. Yes. I hope you're clear with this. You want to draw it, please draw it, and then we'll move forward. Now, many times, my dear students, you face a little bit of a problem. What problem you face is that, ma'am, this imagination takes a lot of time and we have to solve the questions quickly. So, is there any trick we can use to find out the coordination number? Yes, there is a trick and I'll make you explain that trick, my dear students. Now is the right time to tell you the trick. Okay, so now let's discuss about the trick. How to find coordination number? Just looking by at the distance. You only have to find out the closest distance at which you want to find the coordination number. If you correctly calculate the distance, you'll very easily calculate the coordination number as well. How is that? Now just see. Okay, so this is the atom where this is your atom in reference. Rest are your phase diagonals, and don't understand this, it's fine. I'll just make you understand. Let's talk about a primitive unit cell. In a primitive unit cell, we initially calculated the coordination number that came out to be, your first coordination number calculated to be 6. Now you'll just see the trick. I'll just write the trick first and then I'll make you explain. Okay, so you write here distance and then here write the coordination number. Okay, so my dear students, if your distance is A or 2A or A by 2 or any multiple of A, edge length A, any multiple of edge length A, your coordination number will always come out to be 6. Your coordination number will always and always come out to be 6. If your edge distance is some multiple of root 2A or A by 2 root 2, or let's say A by 2 root 2, something like this, your coordination number will always come out to be 12. Be it anything, any multiple of root 2, the coordination number will come out to be 12. Let's see. If your distance comes out to be root 3A or A by root 3 or any multiple of root 3 or any multiple of root 3, your coordination number will always be equal to 8. Other than these, let's say root 5A or let's say A by root 7 or something, any distance other than these multiples, your coordination number will always come out to be 24. It will always be equal to 24. This is the trick. You only have to find the distance and just check that this distance is a multiple of which factor, and you can find out the coordination number so easily. Write this down and I'll make you understand each and every part of it. I hope you've written it. Now let's move forward. Let's try to apply that trick in primitive unit cell. We calculated that the first coordination number came out to be 6, right? Yes. Now let's see whether it is 6 or not. This is your reference atom, and you know that in a primitive unit cell, atoms are in contact with each other along the edges. So the minimum distance would be A, because these both will touch each other, or you could say these will touch each other, right? Yes. So can I say that the distance is A? So what will be the coordination number? Any multiple of A is 6. So the coordination number came out to be 6. See, so easy, right? Yes. Let's talk about something else. Let me ask you second coordination number. So you need to find out the second nearest distance in it. What is the second nearest distance? If you see, you can say that this distance is root 2A and this distance is root 3A. Right? Which is a closer distance? Root 2A. So can I say that the distance in the second nearest neighbor or the second coordination number is root 2A? Since it is a distance multiple of root 2, can I say that the coordination number will be 12? And yes, its second coordination number actually came out to be 12. Yes. Right? Yes. Let's talk about the third coordination number. The third coordination number, your distance is root 3A. Just check. This is the third nearest distance, root 3A. And since it is a multiple of root 3, the coordination number will come out to be 8. And if you see, then this is, my dear students, a body diagonal. Yes. One here, one in this, one there. Total 8 cubes, 8 corners. 8 face body diagonals, and the coordination number will come out to be 8. So this is how you only have to find the distance, see which multiple it is, and calculate the coordination number. Okay, perfect. I hope you're clear with this. Please write it down and then we'll move forward. Now let's try to apply this in body-centered unit system. So if you talk about the body-centered cubic unit system, I have to find out the minimum distance. That is what I want. I know that the minimum distance here would be this, which is root 3a by 2. This we have already discussed, right? Yes. So this is the minimum distance. So can I say that first coordination number distance is root 3a by 2. Since the distance is a multiple of root 3, the coordination number would be 8. See, it has one body diagonal. Obviously, 8 other cubes will have body diagonals as well. So total 8 coordination number, and that's true. That's absolutely true, right? The next nearest neighbor would be, my dear students, at a distance of a, right? So second coordination number, your distance is a. So since it is a multiple of a, so coordination number will be 6. This is how you can find out the first coordination number, second coordination number so easily, just by applying the trick, right? Yes, I hope it's clear. You can write it down and then we'll move forward. Your homework is you have to calculate the third coordination number. This is your homework. Which is the next nearest distance? Just calculate it and find the answer. Okay. I hope it's clear. Now let's move forward. Perfect. Next, face-centered cubic unit system. We know that the first coordination number was 12. Now let's see how can it come from the information we know. See, the nearest distance is this, which is equal to root 2a by 2. Right? Yeah. This is the nearest distance. This is the nearest distance. Now, since the distance is root 2a by 2, or we can say this is equal to a by 2 root 2. Is it a multiple of root 2? Yes. Since it is a multiple of root 2, the coordination number will be equal to 12. The coordination number will be equal to 12. This is how you are going to do this type of questions. Just use the trick and solve the questions. They will be solved in bits, in seconds, I guess, right? Yes, perfect. Please write it down and then we'll move forward. I hope you're clear with this. Now let's move forward, my dear students. Now we are going to solve a few questions. Now let's see what all we have learned today. What is the simplest formula of a solid whose cubic unit cell has the atom A? There is a cubic unit system which has an atom A at each corner. So it is present at corners. Okay. The atom B, you have atom B present at face centers. Let's say it is present at face centers. And C, which is present at body center. So it is present at body center. So you have to tell what will be the formula of this particular compound. See, since A is present at 8 all corners, how many corners are there? 8, right? 8 corners, and the contribution is, we know that contribution is NC by 8, we know that NF by 2, and we know that NB. So the here total number of corners are 8 atoms are present, so the contribution is 1. It said that the atoms are present at each face center. You have 6 faces, so you will say 6 by 2, this is equal to 3. Let's say this, you have body center only 1, so 1. So what is the ratio that came out for A, B and C? It is 1:3:1. So you know what is the formula? The formula is A, B, 3C. So A, B, 3C, that is option A. C is your correct answer. This is how you solve these particular types of questions. Okay. Yes, perfect. I hope you're clear with this. Please pause the video, write it down, and then we'll move forward. Okay. Perfect, my dear students. Let's move forward and try another question. The another question says that the edge length of a unit cell in terms of radius of spheres constituting FCC, BCC and simple cubic unit cell is. So my dear students, for solving this types of question, you need the relation between the radius and the edge length. And I know that for primitive atoms touch along the edges, so A is equal to 2R, right? Yes. If you talk about BCC, that is your body centered crystal system, your atoms touch along the body diagonal, and the length of the body diagonal is actually equal to root 3A. So I can say that this will be root 3A is equal to 4R. And for FCC, the atoms touch along the faces, and if they touch along the faces, I can say that root 2A distance is equal to 4R. We have to give A value in terms of R. We have to give A value in terms of R. So A, here A will be equal to 4R by root 3, and here A value will be equal to 4R by root 2, which is equal to 2 root 2R. Okay, so the answer is 2R, comma, you have to first tell for FCC. For FCC it is 2 root 2R. So first value should be 2 root 2R. Then for BCC is 4R by root 3. And for simple cubic, that is primitive, which is 2R. So option A will be your correct answer. See, this is how questions are asked and you have to solve the questions. I hope it's clear. Yes. Perfect, my dear students. You can pause the video, write it down, and then we'll move forward. Can we move forward? Yes, let's move forward. The next question says that lithium crystallizes as body centered. So the system is BCC. Okay. If the length of the side unit cell is 350, so you are given edge length equal to 350 picometer. You have to give the atomic radius of lithium. So my dear students, you know that since it is a BCC structure, so the atoms will come in contact along the body diagonal, and since they will come along the body diagonal, the relation would be root 3A is equal to 4R. You have to remember this relation because questions are asked from these relations only. Okay. And you have to calculate the radius. So R will be equal to root 3 by 4A, which is root 3 into what is A value given? 350 upon 4. Okay. So you only have to solve this part and you will get your answer. The answer will be in picometers. Okay. Just solve this and get your answer. I hope you're clear with this. It was given that it is a body centered cubic unit cell and you were asked the radius, you were given the edge length. You know that in a body centered unit cell, the atoms touch along the body diagonal. So you have to use this relation, find out the value of radius. Okay. Perfect. Let's move forward, my dear students. Let's move forward to the next question. The next question is on your screens. Try the question now. You can try this question on your own, exactly like the previous one. Okay. The question says that the neon atoms has a radius of 160 picometer. So this time you are given the radius, which is 160 picometer. What is the edge of the unit cell? You have to tell A of the unit cell, and the unit cell is face-centered structure. So the structure is FCC. And I know that in FCC, the atoms touch along the face diagonal, and if they touch along the face diagonal, then I can say that root 2A is equal to 4R. I have to calculate A. This is 4R upon root 2, which is 2 root 2R, which is equal to 2 root 2 into 160. So this you will solve and you will get your answer, and the answer will come out to be in picometers. Okay, so this is how we apply the information that we have studied till now. I hope you're clear with this. Perfect, my dear students. Please move forward and then we'll solve the questions. Let's solve another question. The question is on your screens. It is an assertion reason question. So try to do this. The question says that a crystal having FCC structure is more closely, this is a word which is closely. it is more closely packed than a crystal having BCC structure. Now see, my dear students, you know that packing fraction of FCC is 0.74 and the packing fraction of BCC is 0.68. So which has a higher packing fraction? Your FCC. Then obviously it is more closely packed than BCC. So the first statement says that FCC structure is more closely packed than the BCC structure. This statement is true. This is true. Okay. Reason says that packing fraction for FCC structure is double than that of BCC. Is 0.74 double of 0.68? No. So this statement is false. Your first statement is true, but your second statement is false. Okay. Perfect. This is how you will be solving this type of questions. Please write it down and then we'll move forward. Next. The question says that okay, we don't have A and B here. Find out the coordination number for point A and B. I'll mark A and B on my own then. Let's say your A point is here and your B point is, let's say, where? B point is here. Try to do this question. It says that you have atoms here. Okay, so it is a body centered cubic crystal system. I hope you can see, because atoms are present at the corners and at the center. You have to tell the coordination number of A and B. See, if you see between A is a body centered cubic system, so it will touch along the body diagonal. So it will touch B part. This is root 3 A by 2 distance, and since it is a root 3 multiple, so whenever it is a root 3 multiple, the coordination number is 8. So the coordination number for A is also 8, and for the coordination number of B will also be 8. So 8 comma 8, option B will be your correct answer. So this is how you have to solve the questions. Questions will be asked from you on the basis of coordination number. Okay. I hope you're clear with this. Perfect, my dear students. You can pause the video, understand this, write it down, and then we'll move forward. Next question. It is another assertion reason question. Try to read the assertion and reason. It says that packing efficiency is maximum for FCC. Till now, whichever we have studied, we know that the packing fraction of FCC is maximum, which is 0.74, because for primitive it is 0.52, for BCC it is 0.68, and for FCC it is 0.74. So the maximum is for FCC. So this statement is true. The second says that coordination number is 12 in FCC structure. Yes, we did calculate and the first coordination number came out to be 12. So this is absolutely true. Right? Yes, perfect. I hope you're clear with this. Pause the video, write it down, and then we'll move forward. Let's solve another question. The question is on your screen. Try the question yourself, my dear students. We've done a lot of questions exactly like this. The question says that gold has a FCC lattice. So this time you have a FCC lattice and the edge length A is given to be 407 picometers. You have to tell the diameter of the gold atom. So you need the radius. Since it is FCC, so you know that the atoms will touch along the face diagonal. Since it will touch along the face diagonal, so root 2A will be equal to 4R. So R will be equal to root 2A upon 4, which is equal to A by 2 root 2, which is equal to 407 upon 2 root 2 picometer. You just have to solve this and you will get your answer. Very easy. No, you have to calculate the diameter of gold atom, not the edge radius. So the diameter D would be equal to 2R, which is 2 into 407 upon 2 root 2. You can cancel 2. So 407 upon root 2 picometer will be the diameter, and this will be your correct answer. This will be your correct answer. I hope you're clear with this. Perfect. You can pause the video, write it down, and then we'll move forward. Okay. Okay, my dear students, before ending the session, we need to understand one little topic, and it is very interesting. The topic is density. Okay, you have to calculate the density of a unit cell. Now, my dear students, how do you calculate the density? In general formulas, I know that density is equal to mass upon volume. So if I have to calculate the density of a unit cell, so I need the mass of atom, total mass of atoms divided by total volume of the unit cell. Now you will be like, ma'am, why the total mass of atoms? Because, my dear students, the unit cell is made of only atoms. It doesn't have anything. So what will be the total mass of the atoms? That will be the total mass of the unit cell. And then you can calculate the volume also, and you can find the density. Okay, so now, my dear students, let us say that M is the mass of atom, of one atom. Now if my dear students, M is the mass of one atom, right? M is the mass of one atom, or you might say, let's say that capital M, it is the molar mass of one atom. It is the molar mass of atom. I hope it's clear. Yes. Let's say that R is the rank of unit cell. So what does R tells you? It tells you that how many atoms are actually present in the unit cell. You know the mass of one atom, and you know how many atoms are present in the unit cell. So can you say that the total mass of the atom, total mass of unit cell will be equal to rank into molar mass of atom, right? Yes, since it is the molar mass, it is the mass of 1 mole of atom. So to calculate the mass of one atom, I need to write here mass of one atom. And if I want to calculate mass of one atom, then I can multiply R by molar mass, and then I'll have to divide it by Avogadro number, right? If M is the molar mass of Avogadro number of atoms, then mass of one atom would be molar mass upon Avogadro number. Right? Yes. This is the total mass of the unit cell. Unit cell, the volume of unit cell will be equal to A cube, because still we are considering cubic unit cell, and A is the edge length of the unit cell, where I can say A is the edge length of unit cell. Edge length of unit cell. Right? Yes, ma'am. Perfect. I hope it's clear to you. We calculated, we know the molar mass. Molar mass is for Avogadro number of particles. If you want to calculate for one, you'll have to multiply the molar mass by Avogadro number. R is the number of atoms actually present in a unit cell. That is the rank. So if I multiply the mass of one atom to the rank, I'll get the total mass of the unit cell, total mass of all the atoms present in the unit cell. Yes. So now just calculate the density. Your density will be equal to rank into molar mass upon Avogadro number into volume, which is A cube. This is the formula. This is the required formula. This is the required formula for calculating the density of a unit cell. This is how you calculate the density of a unit cell, where, my dear students, R is the rank of the unit cell, M is the molar mass of the unit cell, A cube is the edge length, volume, and Na is the Avogadro number. I hope you are clear with this. How do we calculate the density of a unit cell? If you want to write it, you can pause the video, write it down, and then we'll move forward. I hope you've written it. Now you can write this. Better is write this down as small d, because we generally write density with small d, na? Yeah, perfect. Now let's try to solve a question. Let's try to solve a question. How questions are asked on this part. The question says that silver forms CCP lattice. So when you are said CCP, this means FCC. Okay, never ever forget CCP means they are talking about FCC structure. Okay, so silver forms FCC lattice, and X-ray studies of its crystal show that the edge length of its unit cell is, so you are given edge length to be 408.6 picometers. You have to calculate the density of the silver. I know that density is rank into 4 by 3 pi r cube. Sorry, I started writing the formula for packing fraction. R into molar mass upon Avogadro number into A cube. So now, my dear students, you have to keep a few things in mind. First, it is a FCC structure, so we need to calculate the rank. Rank will be, is it a FCC structure? Yeah, rank will be 4. I hope all of you remember that rank for FCC is 4. Yes. Rank for FCC is 4. R I know. Molar mass I am given, right? Avogadro number I'll divide. Now I want A value. Always remember, my dear students, your density is always calculated in grams per centimeter cube. So your mass should be in grams per mole and your edge length should be in centimeter. Your edge length should be in centimeter. Okay. Now, just see. Since the atomic mass is 107.9 U, all of you remember that whatever the atomic mass is, the molar mass is always in grams per mole. So I can say that molar mass will be 107.9 grams per mole, because only unit changes, the numerical value remains the same, right? Yes, perfect. So now we have calculated this and this. We need the edge length in centimeters, but we have edge length in picometer. So we'll have to convert picometer into centimeter. How are we going to do that? You know that 1 picometer is equal to 10 raised to the power, this is picometer, minus 12 meters. Your 1 picometer is equal to 10 raised to the power minus 12 meters. And my dear students, 1 meter is equal to 10 raised to the power minus 2 centimeters. And 1 meter is always equal to 10 raised to the power minus 2 centimeters. So I can write 1 picometer as 10 raised to the power minus 10 into 10 raised to the power minus 2 meters. I know that, just a second, I just made a mistake, my dear students. I'm sorry. 1 centimeter is equal to 10 raised to the power minus 2 meters. Okay, yeah. So I can say that this particular part is actually equal to 1 centimeter. So 1 picometer is actually equal to 10 raised to the power minus 10 centimeters. This is something which you need to, which you should know, or you should know how to calculate it. Okay, these are the things which you have studied in the mole concept chapter in your 11th. If you haven't, you want to revise it, then what do? You write the relation here. You write 1 centimeter is equal to how many meters? You open it out and you can say that 10 raised to the power minus 2 meter can be written as 1 centimeter. So you wrote it as 1 centimeter and you got 1 picometer equal to 10 raised to the power minus 10 centimeters. Okay. Yes. Now, I know that 1 picometer is 10 raised to the power minus 10 centimeters. Then edge length A will be equal to 408.6 into 10 raised to the power minus 10 centimeters. So this would be 408.6 into 10 raised to the power minus 10 centimeters. This is how you convert picometer to centimeter. Okay, perfect. I hope you're clear with this. Now you can put all these values in the formula. So your density would be equal to rank 4 into molar masses 107.9 upon, what do we take the Avogadro number value? 6.023 into 10 raised to the power 23 into A cube in centimeters, 408.6 into 10 power minus 10 whole cube. This is how you will be finding the density. You have to solve this and you will get the density in gram per centimeter cube. Gram per centimeter cube. Okay, yes, this is how, my dear students, we calculate the density. Yes, density questions are need a little bit of the calculations, but other than that, the questions are very easy. All the questions are formula based. You only have to put the values. Just take care of the unit system. Just take care of the unit system. If you want to write it, pause the video, write it, and then we'll move forward. With this, my dear students, let's end our session today. We have discussed a lot of things today. We have talked about the packing fractions and coordination number of all the type of arrangements. Also, we calculated the density. This is something which is very important. Generally, questions are asked from this part. So, you have to revise this part. In the next lecture, we'll be discussing about various types of voids. Again, this chapter is going to be super, super, super interesting. You just have to be patient and be energetic and be happy about learning new things. We'll meet in the next session. Till then, all the very best. Thank you so much.